Good morning, this is your Stat Sensei, Mr. Spensei, and this is an introduction to sequences and slope-intercept form. So our warm-up, it says find the next three terms in each of the sequences, and we have 4, 7, 10, and 13. So when I look at this sequence is changing by 3. So it's going up by 3. It's a plus 3 as we move in this direction. So 4 plus 3 is 7. 7 plus 3 is 10. 10 plus 3 is 13. So the next one would be 16. When I add 3 to that, add 3 to 16, I get 19. Add 3 more, and I get 22. Just that simple. All right, this one, also finding the next three terms. Well, from 5 to 12 is changing by 7. 12 to 19 is changing by 7, and 19 to 26 is changing by 7. So 12 minus 5 is 7, 19 minus 12. So that's the difference between them. So if I add 7 to 26, I get 33. I add 7 to 33 and I get 40. Add 7 more and I'm at 47. All right, so we're going to continue on with this. And the first thing we're going to do is we're going to learn how to write the rule for the pattern. All right. And to do that, the first thing we're going to do is make a chart of values. And it's not that I really want to rewrite this, but I didn't leave room. So I'm going to have to 4, 7, 10, and 13. And being very creative, this is my first value, second value, third value, and fourth value. Leave a little bit of room on this side because we're going to have to add something on this side. And I just number them 1, 2, 3, 4. And I always start off that way. And then I'm going to write blank parenthesis blank and put an N in there. So blank and blank. And I need to find the common difference. Well, we just said that the common difference, the difference between them was 3. So I'm going to drop a 3 in that first blank because that's the common difference. So that's my CD, or common difference. And then I need my zero term. All right. So we have 4, 3, 2, 1. So this needs to be 0. Well, the numbers get bigger if I go this way. I'm going to put B for big and S for small. So 13 minus 3 is 10. 10 minus 3 is 7. 7 minus 3 is 4. And 4 minus 3 is 1. And that happens to be a plus 1. And whatever the sign is, I'm going to need that. So my zero term is plus 1. So my rule is 3n plus 1. Now, as it turns out, this is very similar to slope-intercept form, which is just plain old y equals mx plus b. And guess what? These are my x's, and these are my y's. But if I wanted to rewrite this in y equals mx plus b form, I'd go, okay, well, here's y equals mx plus b. This is the equation. And then I would just change it and go, all right, y equals 3x plus 1. So this turns it into a linear equation, and this is just the rule for the sequence. Okay, so let's try this next one. 5, 12, 19, 26. Well, we're going to start off again by making that table. So 5, 12, 19, 26. 1, 2, 3, 4, because we always start at 1. We leave us a little space to add the zero term. And then we know, okay, we're going to have to do blank and blank. And the reason I'm putting it in parentheses is to remind us to multiply. We can use the multiply sign, or we can just put it in parentheses, blank and blank. We know this is my common difference. This is my zero term. And the difference between them is 7. And it happens to be a positive 7, and it goes in front right here. So we have 7n. If it had been negative, we'd put a negative, but it's a positive, so we don't need to put a plus sign there. But now we need our zero term. So I'm just going to add a zero. And in this case, we're going down by 7. So this is the big numbers. The numbers are getting big and they're getting small as we go this way. 26 minus 7 is 19. 19 minus 7 is 12. 12 minus 7 is 5. 5 minus 7, and just in case you're not good at that, you can always grab the calculator or the Desmos and go 5 minus 7, and we get negative 2. So we find out that this is a minus 2, and like I said before, we had to put the plus sign here. We're going to have to use the minus sign, so 7n minus 2. So my rule is 7n minus 2, and that's my rule. Writing it into slope-intercept form, or y equals mx plus b form, we have y equals mx plus b. So this is going to be y equals 7x minus 2. Now, please don't forget, these are my x's, these are my y's. All right, continuing on. Find the rule for the pattern 44, 39, 34, 29. This one's going to be a little bit different. So 44, 39, 34, 29. Now, it doesn't really matter which ones I put on top, whether I put the x's on top or the y's on top. And just to demonstrate that, I switched them this time. So these are my y's, and I got to put my x's down here, which means this is going to be 1, 2, 3, 4. It's up to you how you do it. I usually like the x's on the, I usually put it the other way, but I wanted to show you that it didn't matter. And we know it's going to be blank, parenthesis, blank. So blank and blank. And what's my common difference? Make sure you're taking the common difference of the y's. Well, it turns out I went down 5 for this one, and I went down 5 for this one, and I went down 5 for this one. So 44 minus 39 is 5. 39 minus 34 is 5. 34 minus 5 is 29. So this time, as we go this way, we're getting small, and this is big. But regardless, we know our common difference this time happens to be a negative 5. So this needs to be a negative 5. And then we need our zero term. So what is it when it's 0? Well, we're getting bigger this way. So that means I have to add, because it's going to be 29 plus 5 is 34. 34 plus 5 is 39. 39 plus 5 is 44. So 44 plus 5 gives me 49. All right. And this is a positive 49. So this would mean negative 5n plus 49. So my sequence, or my rule, is going to be negative 5n plus 49. And that's my rule. Writing it into y equals mx plus b, it's going to be y equals mx plus b. And we just keep the y just the way it is, and we're going to write y equals negative 5x plus 49. So essentially, my zero term is my y-intercept, or my b. All right? And we'll talk more about this in our next, on Friday's video, but hopefully that will help you with that. Let's go ahead and look at this, or what happens when we look at it on a graphical basis. So here we have 4, 6, 8, 10, 12. Write the rule, the linear equation in slope-intercept form, make a t-chart, graph the function, all that stuff. So all the fun stuff we just did, you're like, that was lots of fun, Mr. Spencer. Oh, I'm so glad you enjoyed it. So 1, 2, 3, 4. And in this case, we have 1, 2, 3, 4, 5 numbers. 4, 6, 8, 10, 12. And it's going to get a little, we're going to be a little bit tight on space here, I can see. I have to add a little bit for the zero term. And it turns out, and remember, it's blank and blank. And this is my common difference. This is my zero term. So what are we changing by? Well, we're getting bigger as we go to the right. So this is big, this is small. So we're adding 2, so this is plus 2. And we need to then come back and find our zero term. So what is it when x is 0? So when x is 0, and don't forget, these are my x's and these are my y's. That's going to be important in a moment because we make a t-chart and graph. So 4 plus 2 is 6. 6 plus 2 is 8. 8 plus 2 is 10. 10 plus 2 is 12. On the other hand, if I go backwards, I have to take away 2, and this becomes a positive 2. So we end up with 2n plus 2. So in slope-intercept form, which is simply y equals, I should write the rule directly. The rule is 2n plus 2. That's our rule. Then in slope-intercept form, we have y equals mx plus b. So this is going to be y equals, replace the m with a 2, replace the n with the x, and this goes right there. So y equals 2x plus 2. That's slope-intercept form. It also asks us to make a t-chart. And this is going to be simply 0, 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 12. So let's graph those points. So at x equals 0, we have positive 2. At 1, we have positive 4. At 2, we have positive 6. At 4, we have positive 10. Oh, excuse me, we have 3, we have positive 8. I skipped 1. 4, we have positive 10. And at 5, we have positive 12. Now, if we were just graphing the points, it would look like this. If we wanted to turn it into the y equals 2x plus 2 line, we just need to add a straight edge to it and connect those dots. So let's go ahead and do that so we can see that we have a nice linear function here. Oh, look, we use that keyword function. Why? Because the x's did not repeat. So there we go. Something like that. All right. The next one, write the rule and write the linear equation slope-intercept form, make a t-chart and graph the function. So we're going to do the same thing as we just did. And we have I'm going to make sure I have enough room. 1, 2, 3, 4. So 1, 2, 3, 4. And we have 8, 5, 2, negative 1. And we know we're working with a blank in blank, where this is my common difference and this is my zero term. Well, we're going down, so this is negative 3. So my common difference in this time is 3 because this is getting small as we go this way. So 8 minus 5 is 3, 5 minus 3 is 2, 2 minus 3 is negative 1. All right, so that tells me this is that. Then we have to go the opposite direction to get our zero term. So I'm going to have to add 2 plus 3 is 5. 5 plus 3 is 8. 8 plus 3 takes me to a positive 11. So we have negative 3n plus 11. So our rule is negative 3n plus 11. That's our rule. Now we want to do it in slope-intercept form, which is just going to be y equals mx plus b. So y equals negative 3x plus 11. And lastly, let's go ahead and plot make our t-chart. X, Y, and we have 0, 1, 2, 3, 4 points. And then we have 11, 8, 5, 2, negative 1. So let's graph those points. So we have a point at 0, 11, which is right here. Then we have one at 1, 8, then 2, 5, 3, 2, and 4, negative 1. And those kind of line up to make a straight line, and it should, because I told you it's a slope-intercept form. It's a linear function. It's a linear function. And even though we're just graphing points, let's go ahead and connect them just so we show that we have this beautiful, nice line. All right, for this linear function. And I use the word function because x does not repeat. All right. I hope that helped. Look forward to seeing you on the next one. Thanks for watching.